Okay, go ahead, Ken, sorry.
Okay, I really am excited to be here and to welcome everybody here for a discussion about the mediator agents and the work that we've contributed on that effort. Indicio is committed to the open source community and to the growth and adoption of decentralized identity. This project is building on the efforts of the Akapai community to establish a mediator agent functionality. And we encourage you to leverage this, this work, to use it, enhance it, adopt it, and then where possible, contribute back any enhancements that you make so that we're able to, as a community, benefit from that. We believe that we're stronger together if we all work together to promote the open standards and and improve the technology stack. We all benefit from that. Next slide. In addition to the actual code contributions, we have been focusing on putting together training materials for how to use the mediator agent and to interact with it. Those are listed on our website. Those are optional. You can use the technology without any help or assistance from us, but where you want to go faster or learn about it more quickly, there's an in-depth training available. Also, there's some, on the roadmap, there are additional features. I'm not going to talk about those. I'll let Daniel and Sam discuss the potential and where we're going with it. But this isn't the end of the project. It's one step along the way. Next slide. The different standards bodies, for those of you who are not familiar with this work, this is built on top of the Aries Cloud Agent Python work that is at the URL listed on the screen there at the Aries Cloud Agent Python repo. It's leveraging a number of features from the DIDCOM specification and some of the RFCs there as well. So there's an additional reference if you want to look up and find out more about the particular protocols that are involved. You can go reference it there. We try to participate as much as we can in these communities and to promote the standardization of the interactions so that they're interoperable among all of the different agents that might be deployed across the world. And with that, I'll get out of the way and let Sam and Daniel talk about the actual mediation.
Sam and Daniel?
So quickly, I wanted to offer, sometimes in these discussions, it's hard to know exactly what you're talking about and where we are. Actually, I had this slightly out of order. If you'll skip ahead to the first diagram slide. Yeah. So my goal is to provide a "You Are Here" map in the conversation that we're talking about to help anyone that's a little less familiar be oriented to the conversation that we're having. And this is sometimes helpful because there's a lot of topics here to talk about. And when we're having a narrow topic, knowing where the narrow topic exists is useful. So I threw together a diagram here to try and explain the stuff that we're actually talking about with mediator agents today and why they might be used. Daniel will go into much more detail here, but I wanted to provide a high level overview that hopefully will orient to what's going on. Mediator agents, as Daniel will talk about, are useful in a handful of different cases. One of them is when you have a mediator agent or an edge agent behind a firewall. A mediator agent can be used to handle that. That's common in the case of an enterprise agent, for example, that's issuing credentials or other enterprise type things that happens to exist behind a firewall, and a mediator can help there. Perhaps the most common use for a mediator is to enable agents to run on open source or on mobile devices. You can't HTTP post to a mobile phone, and so mediators help bridge that last mile gap there. And on the right, I have another example of a mediator and an app. The difference here is that there are vendors in the ecosystem that provide mediator services and a mobile app bundled together. And so if you're using something and you're unfamiliar with the fact that a mediator is involved, that's okay. When provided by a vendor, those are often bundled. And so a lot of the complexities there are in fact hidden from for a nicer developer experience as that comes along. And so the next slide, Maya, I've scribbled a little bit, and so we are. This is what we're talking about today. Our today's mediator focus is the mediator agents that are using open source protocols for coordination. This is particularly useful when you want to coordinate between two separate software projects that are not provided by a vendor bundle. And so if you have a mobile app and you're seeking a mediator, or you have two open source projects you want to move to use together, that's what we're talking about today. There are portions of message forwarding, and Daniel will get into this, that are necessary for the entire ecosystem to support, and there are portions that are optional depending on how you want to coordinate with a mediator. And so it's worth bringing that up. My other role in today's presentation is to answer questions. I'll be monitoring the chat, and I'll be able to answer any there, or I can bring them up to Daniel as he presents, so that we can make sure questions get answered. So if you do have questions, please drop them in the chat, and we will get to them and answer your questions and see what we can do to help. Awesome.
Cool. So I'll go ahead and take the screen share from Maya here.
Great. Please go ahead.
Yeah. Okay.
Thank you, Sam.
All right. How's that looking for everyone?
Looks good, Daniel.
Cool. All right. So let's see. I guess I'll just start off with a brief introduction of myself. I don't think I'm as well known as Sam is in the community. So just to give me a little bit more street cred here, I guess. So I'm Daniel Bluhm. I'm a software engineer at Indicio, and I've been in the decentralized identity community for a while, starting off at the Sovereign Foundation about 3 years ago. I've had my hand in a few different things in the Aries community, the Aries static agent library, the Aries protocol test suite, the Aries toolbox and the corresponding plugin for Akapai. I also did a JavaScript library for DidCom that's now in the Decentralized Identity Foundation. I haven't done much with that in a long time though, so not sure where that's at. And I'm also one of the top contributors to the Aries Cloud Agent Python repository outside of the BCGov team themselves. So I've had my hand in the identity community, for identity agent community specifically, for a while, since before it became the Hyperledger Aries project. And I've thoroughly enjoyed being a part of this community, and I'm excited to be able to talk to you guys today about mediation. Let's see, so as Sam pointed out, the concept of mediation is not new, neither is the implementation. We've known that this is a piece that is needed for a long time, and vendors have been filling that gap with their own solutions to enable their mobile apps. So what we're talking about today, and what is new, is the coordinate mediation protocol, and an open source implementation of that protocol to make a open source mediator. That's what we've been working on with SICPA and the government of British Columbia to bring to the Aries Cloud Agent Python repository. So my goal for this meetup today is to give you the groundwork of what mediation is at a conceptual level, and a bit of a crash course on the coordinate mediation protocol. So you know where it fits into the bigger picture, so you can place it in your agent architectures, or even give you a good head start on implementing the protocol so you can interact with a mediator supporting the coordinate mediation protocol, or do it yourself and implement it for your agents. So I've got enough content to talk about this for quite a while, but please, if you have questions, feel free to ask, and Sam will moderate that for us, as he said. So cool. So Sam talked about this stuff. So I'll start off with why we need mediation, which is a bit of a review from what Sam just said, but just getting into more of the conceptual details, I guess, of where mediation fits in. So at the end of the day, one of our primary goals for DID communication is to have secure communication between two parties, so they can exchange credentials, present proofs, or just send chat messages to each other, whatever. And when you have two servers, where you have control of the network infrastructure, it's relatively straightforward to just have these two agents talk to each other directly. They've got a reliable, consistent IP address that's not going to change frequently or anything like that, and they're reachable from the outside world by that IP or a domain name or what have you. So for Bob to send a message to Alice in this context, all he has to do is just post a message. But when it comes to mobile agents, that gets more complicated, of course. The IP addresses of mobile phones change frequently as you switch cell phone towers or from Wi-Fi to data or whatever, or just could be altogether disconnected. So if Bob wants to send a message to Alice to her mobile device, we can't just post that message directly. And that is the problem that mediation is seeking to solve. So that mediator acts as a high availability, reliable endpoint for mobile or otherwise inconsistently reachable devices, such as a server behind a firewall, for instance. So then by providing that consistent endpoint, Bob can post to the endpoint and Alice can retrieve the message from the mediator. This is how mediation works at a very high level. So now I'll kind of get into some of the details between the differences between directly messaging and mediation and the kind of overhead that's added with mediation. So starting off with the differences in the messages themselves. So as you might imagine, there are some extra considerations for the packaging of the message when it goes through a third party in order to maintain the security of the message. So starting off at the message payload, it actually stays exactly the same, which makes a lot of sense. It's the application logic. It wouldn't make sense for it to change just because it was routed through something else. But just as our example here, we have our basic message with our content of your hovercraft is full of eels. And this, again, stays the same. The encryption envelope also remains the same for this layer. So this is how Alice secures a message for Bob. These attributes are, the fiddly crypto bits in order to make sure that message is passed securely with the base64 encrypted payload being inserted into the ciphertext field. So the differences start here then. In order to have this message mediated, passed through a mediator, that inner encrypted envelope needs to be wrapped in a forward message addressed to Alice. So we have our routing 1.0 forward message type with Alice's public key as the to field, and then the message, the encrypted envelope message, is here as the payload. And then that layer is encrypted again, but this time for the mediator instead of for Alice, and which again looks very similar to that inner encrypted envelope, except with that to field differing. And then the encrypted payload inserted here is the value of this encrypted.
Hey, Daniel, we're getting a tiny bit of background noise on your audio. Can we check your mic jack and see if it's plugged in all the way, or?
Yeah.
Oh, that fixed it, whatever you did. Can I hear you still? Yep.
Is that any better?
That's way better. Thanks.
Cool. Hopefully that's better.
The chat was trying to blame it on your landscaper trimming the bushes, but
okay.
That would, yeah.
So to demonstrate how that message would flow from Bob to Alice, then through that mediator, Bob prepares this message with the multiple layers, and then passes that on to the mediator, and the mediator unwraps that outer encryption envelope, is able to inspect the forward message with the to field for Alice's key, being Alice's key, looks up in the routing tables the agent that it should be sent to, which is Alice in this case, and then sends the message off to Alice, who then can inspect the decrypted message. So with some of that context in mind, I wanted to take the time to disambiguate or clarify rather the differences between another concept inside of the identity agent ecosystem, which is that of a relay. So if you're paying attention as the message flowed along here, we used this to field in the forward message to determine the destination for this message. However, if you pay attention to the encryption envelope, that same information is available inside of the encryption envelope. So it's possible to have this message passing work by using that value. And this kind of message passing is referred to as relaying, where the thing in the middle is a relay. So the differences between a mediator and a relay then are that that outer wrapping in the forward message versus just passing it along directly. And there's a couple of benefits and disadvantages to both systems here, so I'm going to call those out. So for a relay, the benefits are that it's just simple. There's no extra message preparation, but it has the one rather large disadvantage of there being no way to distinguish messages intended for the relay versus messages intended for other agents that it's relaying to. So the routing is implicitly handled. So messages, a relay has to process messages differently than other agents would in order to determine whether it's destined for it or whether it's intended for another recipient. Mediators, on the other hand, are explicitly routed. We have that to field, which is it's clearly called out, I guess, as the value used to route on. And with the potential there for using other values, at this point, it's just keys, but you might imagine that DIDs could be used there as well. And this also affords us an extra layer of preventing metadata leak about our messages. So between, going back to this diagram here. So in the hop between Bob and the relay, the only values actually visible from the outside world are the recipient key of Alice. So it's just that to field, which is visible. So it's already pretty minimal, but with mediation, kind of jumping back here, sorry, we only see the recipient key for the mediator in the hop between Bob and the mediator. So it's relatively minor, again, but that's one of our primary differences between the relay advantages versus mediator advantages. And this comes, of course, with the added complexity and extra message preparation required on the part of the sender of messages, which is just kind of inherent in this more explicit routing mechanism. So you might wonder, why would you use a relay versus a mediator? And I've called out a few example use cases here. So you might use a relay as a converter from one transport type to another. So you could imagine there is a relay sitting on your network that receives messages via HTTP and then relays that message on in Bluetooth to another device. With the advantage there being that that transfer from one transport to another is transparent to the senders of messages. They don't need to be aware of the fact that you are switching this message from HTTP to Bluetooth in order to send the message. They just encrypt the message for you and send it along, and then it gets handled within your infrastructure, which kind of draws us into the next point of internal routing with a very specific example of multi-tenancy, which I'll explore in a little bit more detail in just a second. And then just general indirection. You might think of this like mixed-net style services, such as the Tor network, where it's just bouncing messages along a predefined path, or a random path too, I guess, in order to make it more difficult to trace the sender and recipient of these messages. And there are other potential use cases, of course, beyond these that you, I'm sure, could think of. So to explore the multi-tenancy example just a little bit more, so in a multi-tenanted agent, at least to give a concrete example, this is how it's implemented in Akapai as of today in the master branch. We have a base wallet with multiple sub-wallets, and that base wallet is acting as the gateway into the sub-wallet infrastructure, and it provides the relay functionality for messages coming in. So if we have a message destined for Alice, it arrives at the base wallet, and then the base wallet inspects that to field and then routes it to the sub-wallet, who is the intended recipient for that message. Another interesting point to call out here is that you can actually couple this infrastructure with mediation. So they're not exclusive to each other. You could have a mediator on the outside, which provides the step from the mediator to the base wallet to the outside world. And then the base wallet would again process the message and send it to sub-wallets. And this is a possibility being actively explored for having more efficient multi-tenanted agencies in using Akapai. Okay, so now that we've gotten kind of some of the basics of mediation out of the way, as well as the differences between relay and a mediator, in order to get that explicit routing that we defined as being an advantage of mediation, there's some coordination that needs to happen beforehand. And that's where the coordinate mediation protocol comes into play. It's very aptly named. So this protocol provides two primary groupings of messages, one for requesting mediation and one for maintaining the key list that the mediator uses in order to route messages to their destination. So the mediation request, rather, has a type of coordinate mediation 1.0 mediate request, and it includes these mediator terms here. So this is currently something that is not well defined in the coordinate mediation protocol, but it shares several parallels with other points of negotiation that we've identified inside of the Aries community, such as negotiating what values you would like to be inside of a credential. So there's some shared thought space there, but the intent behind it is that a mediator and a recipient engaging with a mediator can negotiate the terms under which the mediation occurs. For instance, a mediator might have in its terms the condition that it will only hold messages for a certain length of time, only willing to route for a given number of keys. Recipient terms might be that it's willing to provide payment, things of that nature. So then the mediation deny message is the opportunity for the mediator to say, I don't like these terms. I would like to propose different terms to this, this mediation. In addition to just these terms, you could also pretty easily base this on whether you grant mediation on having been presented with a credential, a proof that shows that you should, or something else associated with the connection that determines whether you are willing to grant mediation for it. Or you could just go the full-on open mediation path and just automatically grant mediation for anybody that comes asking for it, which is the approach that we've taken in the Indicio Public Mediator, which we'll talk about a little bit more in a bit. So then finally, once the mediator determines that the terms are agreeable, it sends the mediation grant message, which includes the information that a recipient would then need to include in its service endpoints of the DIDDoc used in connections with other agents. If that's a little unclear, that's okay. I'm going to come back to this point in more detail in just a minute. So the state machine for requesting mediation is pretty simple. We start off with our initial state. We request mediation, we move to requested, and then we can loop until we decide that we're ready to grant, and then we move to the granted state. So then the other side of the coordinate mediation protocol, the keylist maintenance messages, we have the keylist update, as well as the response here. And there's also some query messages, but I've omitted the details of that from this presentation. It's because it's a little less interesting. It just reports back the messages that you have in your keylist currently. But those details can be found in the coordinate mediation protocol, in the Aries RFC's repository specifically. So the keylist update message informs the mediator of a new key to be mediated, or requests that it remove a key from the key list. So we just have a list of updates, so you can do multiple at once, the key in question and the action that you are requesting for that key. And then the response from the mediator is, again, the key in question, the action taken, and the result of that action, whether that be an error on the part of the client or server, no change, as in the key was already in the key list if you requested to add, or it was not in the key list before if you're removing, and then a success if the action completed without problems. So using those messages, we can set up a connection to be mediated. This is a bit of a complicated flow, so I'll be stepping you through it one bit at a time so we can see all the different facets of it. So typically in a connection, we have these three major steps with the exact details omitted for now. But we have an out-of-band connection invitation, which moves from the inviter to the invitee, who sends a connection request. And then we subsequently send our connection response back. So for the purposes of mediation, there's a few sub-details in each of these interactions that are of particular note to us, and that is when keys used for the connection are created. So at the connection invitation creation phase, we create an ephemeral invitation key, which is used only to encrypt the connection request that is sent back from Bob to Alice. And then later on in the response phase, we create a new long-term connection key to use in the connection going forward. And then that is sent over in the connection response. Okay, so I'm going to pull up an activity diagram. It is found at this link. I will also drop this in the chat. If I can pull that up. So you can follow along if you'd like, in case anything's too small to see on my screen or anything like that. Oops. And I will also zoom in a bit here. Okay, so this is going to be the flow where the mediated agent begins the connection protocol. So we begin with establishing a connection between Alice and the mediator. This happens as normal, so did not explore the details on that one. We have our loop of the mediation request deny until the terms are deemed acceptable by the mediator, who then grants the mediation to Alice and includes that routing key and endpoint that we discussed earlier. So then thereafter, if Alice intends to create a connection with another agent using the mediator as to mediate the connection. So we create our invitation and then send a keylist update message to the mediator, which contains that ephemeral invitation key with the action of add. Alice can then transmit that invitation to Bob out of band and whatever means is appropriate there. And that invitation will have the routing keys reported by the mediator, as well as the recipient keys being the invitation key that Alice just created, and the service endpoint being the mediator's endpoint. So Bob, in creating a connection request, will prepare the message for sending back to Alice. To do that, he will encrypt the message first for Alice, wrap that message in that forward message, and then for each key in the routing keys list from the invitation, we'll encrypt the message and repeat the forward wrapping for all remaining keys in that list. So in this case, it'll just be the one layer, very similar to the diagram that we followed earlier. So then Bob's response is sent to the mediator, wrapped in a forward message. The mediator processes that forward, unpacking the message, inspecting the to field, and looking up the key in the routing tables, and determines that it should go to Alice. And then it sends that connection request on to Alice. So then in the connection response phase, when Alice is creating the new connection keys, she again needs to send a keylist update message to the mediator. And in addition to that, the ephemeral key that we created for the invitation is no longer used. So we can also remove that from the key list as well. So that's what this message has here, our new key and removing the old key. And then the connection response is sent to Bob as normal, since his connection is not mediated. Only the path from Bob to Alice is mediated. And the did doc sent in this connection response will include those routing keys and the mediator endpoint again, similar to the invitation that we pointed out here earlier. So then messages flowing between Bob and Alice after the connection is established will look something like this. The messages are encrypted for Alice, then wrapped in the forward message again, sent to the mediator, who sends it on to Alice, who decrypts the message, and so on. And then messages from Alice to Bob, again, are sent directly and not through the mediator. Okay, that was kind of a lot of detail. I'm going to pause for a drink. If anybody has questions now, would be a great time to ask them if you have them.
Lee, you have a question.
Okay.
Hang on.
If not, then I am going to actually demonstrate.
Daniel, can you hear
actually
me?
connecting to the Indicio Public Mediator
Daniel?
using
Daniel?
the Aries toolbox as kind of a stand-in for a mobile agent.
Hey, Daniel.
This will follow a slightly different flow.
You must
That's
not be able to
okay.
hear us.
The,
Yeah.
I can
mediated
type it in the
connection
chat.
process,
Okay,
and I'll
perfect,
step
thanks.
through that with you as well as I go through the demo. So I'll switch context here a little bit. So here we have the toolbox window, and behind that we have a running Occupi instance named Alice, which has an invitation printed out to the console ready for us to use in just a moment. So I'll move this out of the way briefly. So this is the landing page for the Indicio Public Mediator. It has instructions, general instructions, kind of more vague description of what I've gone through in this presentation for how to use the mediator. But it also has the actual invitation that you need to establish that initial connection between the mediator and our mediated agents. So this is the most important bit here, but there's more to look at here. And while I'm here, I'll also call out that the Indicio Public Mediator is a public service available for anybody to use. Our intent is to reduce the barrier to entry for developing these mobile agents, or just for simplifying your agent development in general. If you want to be able to easily develop behind a firewall without having to worry about tunneling or anything like that. So we want this to be as useful as possible for you. But at the same time, this is maintained on a best effort basis. So the connections and routing tables maintained by the mediator could potentially be wiped out at any time as newer versions of the protocols become available, or new versions of the agent need to be introduced, be updated, or things of that nature, I guess. That being said, we do intend to have deprecation periods. So you will have some warning if that is the case. And again, we want this to be useful. So if you feel that one of these planned deprecations interferes with a demonstration that you have planned, let us know and we'll work with you to make sure we're not getting in your way there. Okay, so preamble out of the way. We're now going to connect the toolbox to the mediator so we can then connect to Alice through the mediator. So we'll copy the invitation URL, paste this into this connected mediator box, and go ahead and connect here. And as you can see, the connection appears and it's labeled as mediator, and I will step through what just happened there. So this looks very similar to before. We take an invitation, and that allows us to establish the connection. But since we pasted it into this connect to mediator thing, we knew that we automatically needed to send a mediation request as well to the mediator. So the mediation request was sent, and we got our grant message back, and the toolbox is now holding on to the routing keys reported by the mediator and the endpoint. So we'll now move into this next side of the interaction, where we will accept a connection invitation. So instead of the mediated agent beginning the interaction by creating a mediated connection invitation, all we have to do now is respond to a connection request that's already been, or rather, a connection invitation that's already been created by the other party. So in this flow, there's only one keyless update message required, and that is for the long-term connection keys created during the connection request phase. So in order to kick off this interaction, I'll slide this window out of the way and grab the invitation from the terminal for Alice and put it into the new agent connection and connect. So to bring that diagram back up real fast, so we've just gone through this whole process here, so I'll step through the remaining piece. So we sent our connection request, and then Alice responded with the connection response, preparing it very similar to the connection request from the other flow, where the response is encrypted for Alice, then wrapped in a forward message, and then encrypted for the mediator, and then sent off to the mediator, and then sent off to the toolbox in this case. So now if we open up our connection to Alice, we can exchange messages between the toolbox and Alice. So I can send a basic message. This is directly from the toolbox to Alice. And we can see that this is a little bit of an awkward flow, I suppose, because this window also gives us the perspective of Alice to the outside world, as well as the toolbox to Alice. So we can also see that Alice received or sent that message, and we can send a message here and see that Alice receives it. So it shows up in two different places. But that is messages flowing between the toolbox and the mediator as depicted in this particular section of the mediation flow diagram here, where the message is encrypted, forwarded, decrypted, and the messages flowing back from the toolbox to Alice are done directly because Alice has not set up a mediator for herself, just the toolbox for that path to Alice. Okay. I'll jump back to my slides here now. So that flow went pretty smoothly, and we were kind of able to skip over a significant detail, which is what happens when there is inconsistent connectivity. So we just had it working where we had an active WebSocket between the sender and the recipient. So the mediator in the middle was able to directly send the message on over that active WebSocket connection. But again, what if it's offline? So in this case, the mediator takes the message and pops it onto a message queue for some policy-driven length of time as specified in the mediator terms or otherwise. And then when Alice comes back on later, Alice sends a message to the mediator, which triggers the mediator to send the queued message on to Alice, having been alerted to the active connection, which has the ability to send messages back along it. So this is how you would retrieve messages from a mediator after coming back from a period of being disconnected. And there's a few, I'll call them gotchas, I guess, about how this is working right now today. So as of right now, this is working by specifying a message with a return route of all, which does not trigger a new message, such as a trust ping with the response request set to false. So the reason why this works is the return route, the semantics surrounding that decorator say, if I get a message with a return route of all, and I have a message on the queue, and there are no other messages to send, then send the message that I have in the queue. This is an implicit message retrieval mechanism, of course, though, and pretty much everybody involved agrees that having an explicit mechanism for passing messages, for retrieving messages rather, is a good idea. Just being able to unambiguously request that retrieval. So Sam Curren actually proposed the pickup protocol a while ago, but that RFC has since kind of morphed a little bit, and it has some issues that make it difficult to implement at this point in time. So it is not currently implemented, as far as I know, in any agents widely used today. So that is a piece of future work that we intend to bring to Akapai, as well as we encourage, of course, support for this in mobile agents who work with coordinate mediation protocol. Sam, is there any clarifications you think I should make there?
Yes, I can, but Daniel,
Since, this is something that you have thought a little bit more about than I have, just wanted to give you the opportunity to speak up if you had any more to say.
Daniel, we can't hear you. You can't hear us. I'm talking, but you can't hear me. You gotcha? No? I sent him a message in chat too. All right. He's focused.
So,
Keep going.
This kind of leads us into a more advanced topic of mediation, which I just wanted to call out and kind of discuss the advantages and disadvantages of briefly. So this is something that, this is a concept that's been around for a really long time. I gave a presentation on message routing at a Sovereign Foundation meetup more than a year ago on the same topic, but we are only now actually having concrete implementations for this today. So the concept is having mediators chained together to provide you increased privacy or just increased flexibility in your routing mechanism. So this is, again, a somewhat complicated flow, so I'm going to pull up this activity diagram, wrong one more time. I think I'm looking at the wrong one again. Is this it? Here we go. Okay. So in order to chain mediators together, the process looks something like this. So we begin with the standard connect to mediator request mediation flow, where the end result is Alice now has an endpoint that she can report to other agents, as well as the routing keys needed to route through that endpoint. So to layer another mediator on top of that, we then would establish a connection with the next mediator in the chain through mediator 0. So messages flowing back to Alice in this established connection would be flowing through mediator 0. And then we update the key list in mediator 0 to have the key of Alice to mediator 1. So then the mediation request and grant come back, and then Alice now has the endpoint set for mediator 1, with the routing keys list now being expanded to including mediator 0 and 1, where the ordering is significant. So as you move through the list, you need to wrap it in another forward and encryption, with the innermost envelope representing the first mediator in that routing keys list. So then from here, it just recurses down through the process. So at the end of connecting to yet another mediator, we have the endpoint as the endpoint of mediator 2 and routing keys for 0, 1, and 2. And again for 3, with the end result of an endpoint of mediator 3 with routing keys for 0, 1, 2, and 3. So then for Alice to establish a connection with Bob and to examine how that message flows back to Alice, the mediator 3 is the one that receives the key list update for Bob, for the key that Alice uses in the Alice to Bob relationship. So Bob, in preparing the message, looks at the routing keys list and then takes the message for Alice, wraps that in the envelope for the mediator 0, which wraps that in the envelope for mediator 1, and for 2, and for 3. And then as it moves from one mediator to the next, each of those layers is slowly unwrapped until mediator 0 sees the forward message for Alice and then sends it off to Alice, and then Alice can use that message. Okay. So this is understandably kind of a complex process, and I think that's partially just inherent in the setup of a complex routing mechanism. But there's some potential here for optimizing this a little bit if this ends up being a really high demand feature, for instance, to simplify just the setup of mediation, which is to be able to specify to a mediator to use a certain endpoint routing keys and recipient keys, rather than relying on the connection from the recipient to the mediator to define those values. So, for example, in order for Alice to set up mediation with mediator 3 in that diagram, it can just communicate with it directly rather than having to speak through 0, 1, and 2. I think this would require changes to the coordinate mediation protocol in order to allow you to make that specification, but it is an option, I guess. Another opportunity for simplifying this process is designated mixed-net services, which is just a mediator service which has a pre-configured indirection route, and it reports that in the routing keys in the mediation grant message. So it starts off with just the endpoint for the mediator providing the service, and has the list of routing keys for each of the hops along the path defined by the mediator service already included there. So Alice doesn't have to worry about going and configuring that all herself. And then another alternative is just to use a relay-based mixed-net altogether and skip this process, which reduces the burden on the sender of messages since they don't have to repeatedly encrypt messages and wrap them in forwards. And you can actually get this functionality basically out of the box with the Tor network acting as a relay by just having it be your endpoint, so to speak, and specifying the exit path out of the Tor network to your agent. So relying on other services which are purpose-built for this kind of indirection is another opportunity for providing this sort of increased privacy or increased security, I suppose, for these messages. So that's the bulk of what I had to talk about today. I wanted to call out some items of remaining work to be done in the whole space of coordinate mediation and just mediation in general. So specifically to the ACAPI agent, we have a need to implement mediated connections for the out-of-band and did exchange protocols. At this point in time, we support the original connections protocol. But if you want to use the new and improved method of establishing connections, which will be superseding the original connections protocol, we will need to add the support relatively soon. This is something that's still being actively worked on inside of ACAPI for the 060 release. So the code for out-of-band and did exchange have not quite stabilized completely just yet. But as soon as that is taken care of, we anticipate this being a relatively quick change in order to get that functionality into it. On top of that, we also recognize that there's a possible need for having webhook events being emitted when you get mediation requests, for instance, or you receive a mediation grant message. So notifying your controllers and your agent architecture of these different events on mediation. There's also probably a good case for arguing that the keylist update messages could have a webhook, which would allow the agent receiving these keylist updates to have a little bit more direct input on whether a keylist update is respected or not, I suppose, or just being able to inspect what's going on in the agent a little bit better as well. And then, as I called out before, the pickup protocol is in need of revision in order to better support mediation in this form. So finally, I just wanted to call out a big thank you to the SICPA team who actually sponsored a lot of this work. Their input as well on the implementation was very much appreciated as we were going through this, as well as the BC Gov team who accepted all this code into their repository and have been very supportive in making sure that we're able to demonstrate it and get the word out on the coordinate mediation protocol and bring it into the mainstream, I suppose. So again, huge thank you to both of those groups. And that is the content that I had prepared.
Thank you, Daniel.
So happy to take questions on any of those topics. I'm happy to go back to topics and step through them more slowly or focus on particular details, whatever would be helpful.
Anybody has any questions? In that case, anybody has any requests for next month's topic?
There might be a good opportunity to talk a little bit more about wallets and UI UX.
Oh, and I've just noticed that I can't hear you guys. Let's see here.
You got us now, Daniel?
Daniel. Anyways, I'll put it in the meetup chat listing there for other topics that we have ideas for.
Yeah, sounds good.
I'd like to call it. I appreciate the questions that we had, particularly the question about HIPAA as it applies to using these messages for secure communication. So appreciate that. Any other questions? You can reach out. We're almost at the end of our hour here, but if you want to reach out to the team directly or on any of the common communication channels, we welcome you to do so. And then if you are looking for a far more in-depth and hands-on thing, then we do have training available as well for how mediation applies into your particular scenario.
Great. And our next meetup will be February 17th, Wednesday, on same time. And please feel free to email me at maya@indicio.tech for any request or any questions you have. And we are very looking forward to seeing you again next month. Thank you so much.
Thanks, Maya. Thank you for everybody for attending.
Thank
Thanks,
you for
Daniel.
coming, everyone. Thank you, Daniel. See you next month.